All right, so remember from class, a permutation is picky, the order matters, combination, order doesn't matter. So when you read a problem, you have to ask yourself which of those things is true, and so that's what this little piece is asking you. Remember, permutation is like you're giving someone a specific job. Combination, you're just getting picked and nobody's getting a special job. All right, so determine whether these things are a permutation or a combination. So selecting 3 students to attend a conference. So you're just picking 3 people, they're not doing a special thing, they're all going together, all equal, so that'd be a combination. Selecting a lead and an understudy. Well, those are different jobs, permutation. Students, assigning students to their seats, you know, like the order matters. It matters where you sit. You know, you don't want one person sitting next to another person that talk too much or whatever. That's a permutation. Selecting 2 stuffed animals to sleep with out of your 10. Well, you're sleeping with both. They're not like getting a special job or anything like that. So combination. President and a vice president for the science club, or treasurer also, that's a permutation. Everybody's getting a specific job. Okay. All right, so over here, that's what we basically need to decide when we're doing our problems. It could just be normal counting. It could be a permutation or a combination. So we'll just see. So what are all the possible 2-digit numbers can be created from these numbers? So 1, 2, 3, 4, 5. So this is going to be a permutation because when you write a number, like let's say I pick the numbers 4 and 1. Well, is that 41 or 16? 2 different numbers because the order matters. So I have 5 numbers. I'm going to do P2. All right, so I grab my calculator, put my 5, math, go over to probability, P2. All right, so there's 20 different numbers you could make. All right, 10 shirts in your closet. You're going to take 6 of them with you on vacation. How many different groups of 6 shirts possible? So first of all, this is a combination. You're just picking 6. It's not like you said, oh, I'm going to wear this one on Monday, this one on Tuesday. You didn't give them specific jobs. It's just 6 shirts that you're going to have to choose from when you're out on vacation. So you got, what, 10, you're choosing 6, right? So 10, math, go over to probability, choose 6. So 210. All right, there's 14 juniors and 23 seniors in the service club. The club is going to send 4 people to the state conference. How many different ways are there to select a group of 4 students to attend the conference? Well, let's see. You got 14 juniors, 23 seniors. So 14 and 23, that's 37, right? 14 and 23? Yeah, sorry. I can't do regular math now. All right, so that's 37, right? Yeah, sorry. All right, so there's 37 kids. Nobody mentioned anything about juniors or seniors. They're just 37 kids. Nobody mentioned anything about jobs. And so we're choosing 4 to go to the conference. So this is going to be pretty big because 37 is a lot, right? So 37, choose 4. All right, oof, 66,045. So that's that many different groups of 4 people. Remember, like the order doesn't matter, so that's a lot of different choices to make. All right, if the members of the club decide they need to send 2 juniors and 2 seniors, so now we're split up into groups. So to pick 2 juniors, I would have 14 choose 2. And to pick 2 seniors, I would have 23 choose 2. And what I have to do with this is I have to multiply those answers together. Okay, because this many choices and that many choices, it goes back to the normal counting that we did at the beginning of class, and you multiply those together. All right, so 14 choose 2, that's going to be 91, and 23 choose 2, 253. So 91 times 253, 23,023. All right, almost done here. Cafeteria, let's see. So sometimes you don't always have to use a formula, you know, you can just like think about it logically. There's 3 main courses to choose from, 4 side options, and 2 dessert choices. How many different lunches can be chosen? So you get 1 of each, right? So you got 3 main course times 4 sides times 2 desserts. Now you could also see this as 3 choose 1 4, choose 1, and 2, choose 1. But this all comes out to 3, 4, and 2. Okay, so 24 choices. All right, down here, serial numbers for a product are to be made using 3 letters, using any letter of the alphabet, followed by 2 single-digit numbers. So 3 letters and then 2 numbers. All right, how many such serial numbers are possible if neither the letters or the numbers can be repeated? So 3 letters. So I got 26 letters in the alphabet. Then I can't repeat, so 25 and 24. You could figure this out using a permutation, but it's also just easier just to think it out like this in a regular counting. And then we got numbers. So digits, we'll just say 0 through 9. So there, 0 through 9, there's 10 digits. So we got 10 for the first spot and then 9 for the second spot. So we're going to get 26 times 25 times 24 times 10 times 9. Oh boy. So 140. So 1,404,000. All right, that's it. I'll see you in class, and we will have a little bit to do these problems here. Don't do them now. Just wait, and we'll get them done in about 15 minutes in class. All right. Bye bye.